You know, we're surrounded by these incredibly powerful, invisible forces all the time. We use them in everything from our cars to our hospitals. But what's really wild is how we can actually control them, how we build these invisible cages to trap them exactly where we want them. So how on earth do you build a cage for an invisible force? Well, let's dive in.
Okay, check this out. An MRI machine. Inside this thing is a magnet so powerful it can literally realign the atoms inside your body. And yet, you could stand right next to it and feel absolutely nothing. There's no stray magnetic field. So how can something so incredibly strong be so perfectly contained?
That's the big question, right? How do you actually trap a magnetic field? Well, the answer is surprisingly clever. It's not about building thicker walls. It's all about using a fundamental law of physics and some really smart geometry.
The main tool we're going to use is something called Ampere's law. Now, don't get bogged down by the textbook definition. Just think of it like this. It's a current counter. If you draw an imaginary circle, or any loop, around some wires, Ampere's law basically says the magnetic field going around that loop is tied directly to the total amount of current that pokes through it. Simple as that.
And you see this every day. Take any regular power cord. You've got one wire inside carrying current to your lamp, and right next to it, another wire carrying the exact same amount of current back. So if we use our current counter and draw a loop around the entire cord, what do you think we'd find?
Yep, they completely cancel each other out. The current going in and the current coming out are equal and opposite. So the net, or total current, is zero. And if the net current is zero, Ampere's law tells us the magnetic field has to be zero too. This idea of cancellation is the secret ingredient to everything we're about to see.
All right, so let's take that powerful idea and level it up. We're going to apply it to a really cool device called a solenoid and see how it pulls off its magnetic trapping trick.
So what is a solenoid? It's basically just a long wire wrapped into a tight coil, kind of like a slinky, and it's designed to do one thing really well: create a super strong and super uniform magnetic field on the inside. But what about the outside? Let's pull out our current counter again. Imagine we slice that solenoid in half and look at it end on. We'd see a row of wires at the top and a row at the bottom. Now let's draw a big imaginary loop that goes all the way around the outside of it. Now here's where the clever geometry comes in. Look at what our loop sees. The current in the top wires is flowing away from us, or into the screen. And at the bottom, the current is looping back around and flowing out of the screen, right towards us. So you see what's happening? For every single wire with current going in, there's another wire with the exact same current coming out. So, when our Ampere's law current counter looks at this whole picture, what's the total? All those ins and all those outs add up to a big fat zero. The total current passing through our loop is nothing. And there it is. That's the big reveal. If the total current is zero, then the magnetic field outside the solenoid has to be zero too. It's not magic, it's just really smart design. The shape of the coil itself forces this perfect cancellation, trapping that powerful magnetic field completely on the inside.
Okay, so there's no field on the outside, but what about the inside? Well, what happens if we draw our loop inside the coil? Look at this. Now our loop only surrounds current flowing in one direction. There's nothing going the opposite way to cancel it out.
So if we break down this internal loop, segment 1 runs right alongside the magnetic field, so it gets the full effect. But segments 2 and 4 are perpendicular to the field, so they contribute nothing. And segment 3? Well, that part's outside the solenoid, where we already proved the field is zero. So what's the result? All of that current works together, unopposed, to create one heck of a strong, concentrated, and uniform field right where we want it.
Now, solenoids are awesome, but they do have one little problem. They have ends, and the magnetic field can kind of leak out and fringe at the ends. So what if we could, just get rid of the ends altogether? That brings us to the toroid, the ultimate magnetic trap.
A toroid is pretty much exactly what it looks like, a donut-shaped magnet. The easiest way to think about it is that we took a really long solenoid, bent it into a circle, and connected the two ends. It's such a simple change, but it has a huge impact.
To prove just how perfect this shape is, let's do our test one last time. We'll use 3 imaginary loops, D1 right in the donut hole, D2 cutting through the coils themselves, and D3 all the way on the outside.
And the results here are just beautiful. First, look at loop D1 in the hole. Does it enclose any wire? Nope. So zero current means zero field. Now look at loop D3 all the way on the outside.
Just like with the solenoid, for every wire with current going in, there's a wire with current coming out. Perfect cancellation, zero field. It's only loop D2, the one inside the coils, that actually encircles the current. And that is the only place the magnetic field exists, strong, contained, and perfectly trapped inside the donut.
So what's the big deal? This is way more than just a neat physics puzzle. This whole principle, using geometry to control invisible forces, is really the foundation for some of our most powerful technology.
So if there's one thing to take away from all this, it's this. You don't need a physical wall to trap an invisible force. You just need clever geometry. By shaping a coil in just the right way, you create a system where all the outside effects cancel themselves out, forcing the field to stay put, strong and concentrated right on the inside.
And that brings us right back to where we started, the MRI machine. That huge tunnel a patient lies in, that's just a giant high-tech solenoid. Its shape is engineered with extreme precision to create a massive, stable field on the inside while keeping the outside world completely safe. It's a perfect magnetic trap.
It really is a mind-bending idea, isn't it? That the shape of an object can completely change how it interacts with the invisible universe. So I'll leave you with this question. What other invisible forces are we controlling every single day just by changing their shape? Think about it.